I'm going to be talking today about how we might assess emotional well-being or affective states in gorillas using judgment bias tests. So I've been working pretty extensively with the bachelor group of gorillas at the Detroit Zoo that includes Chip, Pende, and Congo from left to right on the images on the slide. Typically, welfare assessments focus a lot on observable behaviors. So we might focus on negative behaviors like aggression and behaviors like hair plucking and things that we don't want to see. Also, we can focus on positive behaviors, indicators that animals are doing well and physically healthy, like examining whether they're foraging, whether they're eating, whether they're engaged in reproductive behaviors, and so on. But we're a lot less capable of assessing how they really feel inside because they can't communicate their thoughts and feelings to us like other humans can. So we have to devise tasks that attempt to tap into these kinds of emotion states in order to assess their psychological well-being. So this is the area of my research as a comparative and a cognitive psychologist. I'm interested in the way that our emotional states might affect the judgments that we make. Judgment bias is a particular form of cognitive bias. It's a specific type of task that has been used predominantly to study cognitive bias in non-humans. In these tasks, typically, the animal is exposed to a stimulus that is ambiguous in terms of whether it predicts reward or non-reward. And we look to see if the animal expects to receive reward, and then we assume that that animal is optimistic. If the animal expects not to receive a reward for interacting with the ambiguous stimulus, we assume that that animal is pessimistic. And I think that that cartoon on the right of the slide depicts this kind of representation of interpretation of ambiguous stimuli very well. So in these traditional judgment bias tasks, what we typically do is we present subjects with two different stimuli, one that is associated with reward, which is the positive stimulus, and one that will not be associated with reward, which is the negative stimulus. These stimuli usually appear at the opposite ends of some kind of perceptual gradient, such as the grayscale gradient that you see on the bottom right of the screen, where a white stimulus might be associated with reward and a black stimulus might be associated with no reward. You also see judgment bias tasks that make use of a spatial configuration of stimuli, where the stimulus on the far left from a starting point might lead to reward, and a stimulus such as a bucket on the far right of the starting point may not contain a reward. And then you can look to see on test trials, if you start placing buckets at intermediate locations between the previous positive and negative locations, how quickly an animal approaches. If the animal approaches those ambiguous locations as quickly as they learn to approach the positive location, we can say that that animal is optimistic. If the animal responds as slowly as it learned to do to locations that do not contain food rewards, we would say that the individual is pessimistic. So these are useful tasks, but of course they come with the inherent difficulty of disentangling just a perceptual discrimination as the basis for decisions from the actual mood state. So if the animal responds to the A+ location more similarly as it did to the positive versus negative location, and conversely responds to the A- ambiguous location as it did to the negative stimulus previously, we don't know if that's just because perceptually, and in this case spatially, those ambiguous stimuli are more similar to the positive and negative stimuli respectively, or whether that's really reflecting optimism or pessimism. And in this case, it may be that their responses to the exact intermediate stimulus is the most telling. But if they respond in a very ambiguous way, then that doesn't really tell us much about their underlying states. So we wanted to get away from using a task where the ambiguous stimuli really fell within that perceptual gradient of difference between the previously rewarded and unrewarded stimuli. So to do this, we adapted a version of the Ambiguous Cue Paradigm that had previously been used to study cognition, but not necessarily applied to study emotional affect. We thought that it might be useful because the ambiguous stimulus is no more similar to the positive or the negative stimulus in this task, and you can change the stimuli in very flexible ways. However, a downside is that it does require quite a bit of training. So in training, the individual has to learn how to respond on the what we call NA pairs as well as the PA pairs. So they're presented in the form of a 2 alternative force choice task. 2 stimuli appear on the screen, in our case on a touchscreen computer. And the gorilla is rewarded for touching, in this case, the red square when it is paired with a blue circle. The red square is always correct, the blue circle is never correct. On other trials, they're going to see the red square paired instead with an orange triangle. The orange triangle in this case is always correct, and now they do not receive a reward for touching the red square. So this is what makes the red square an ambiguous stimulus. Sometimes it's rewarded, sometimes touches to it are not rewarded. That completely depends on what it's paired with. In order to test subjects, you need them to reach a criterion of understanding of making the discrimination accurately on both the NA and PA trials. Usually that's at about 80% correct responding. And then at test, what we would do once that discrimination is learned is we would present the ambiguous stimulus with a novel stimulus, something that has no reward history at all. And the logic is that if an individual is feeling optimistic, they're going to gamble that that red square is going to lead to reward on these trials. But if they're feeling pessimistic, they're going to think that touching the red square would not lead to reward, and they're probably more likely to select the novel stimulus. So selections of the ambiguous stimuli on those probe trials are going to be our indication of optimism. So we conducted a study where we trained the gorillas on a set of ambiguous stimuli counterbalanced across the subjects, and we coordinated this in collaboration with research staff at the Detroit Zoo who were presenting a foraging manipulation to the gorillas at the same time. So for 2-week periods, the gorillas either received a baseline amount of forage. They never were completely deprived of foraging materials, branches, and so on, foliage that they really enjoy. They always had some. It's just that in a subsequent 2-week phase, the limited foraging phase, they had less forage materials than they normally would have had. And in the elevated foraging phase, also 2 weeks, they received more additional foraging materials than they would normally have received. So naturally, we expected that the gorillas would behave the most optimistically in our task during the elevated forage phase. This isn't really what we saw. You can see from the standard error bars here that there's quite a bit of variation, and the subjects all responded quite differently. We actually see that Congo, the most dominant of our individual subjects, was actually the most optimistic during the period of limited foraging, which is somewhat surprising. And we do see that Pende is more optimistic during elevated foraging, but Chip was actually very optimistic during the initial baseline phase, choosing the ambiguous stimulus 100% of the time. So we wondered if maybe that was about a preference for that particular stimulus and not necessarily telling us about optimism and pessimism. One of the problems with that particular study was that the gorillas hadn't reached our criterion of 80% correct responding during training before the foraging manipulation was introduced. So we tested them anyways, but we weren't really confident that they understood the discriminations within those 2-week periods. So we engaged in sort of long-term training with new stimuli also assigned to those categories of ambiguous, positive, and negative until they reach criterion. But it turns out that this is a pretty challenging task for the gorillas, and so only Chip reached criterion level of performance and only with one set of stimuli. And again, when we were able to give him the tests, the probes with the ambiguous stimulus paired with a novel stimulus, he chose that ambiguous stimulus 100% of the time, suggesting that he was optimistic. We still wondered if he might have just had a preference for that stimulus, However, he would not have performed at criterion levels of accuracy in training if he was completely biased just to always select that ambiguous stimulus, because he then would not have done well on the PA pairings when it was incorrect. But to further test what Chip was doing, we also wanted to eliminate the possibility that he was simply choosing whatever stimulus was familiar. So we also paired the previous negative and positive stimuli with novel stimuli on some control trials, and we saw that he did not choose the familiar stimuli at super high rates on those trials, even the positive stimulus that had always been associated with reward. So we feel reasonably confident that his choices were reflecting optimism, but we still wanted to get away from a task where specific preferences for specific stimuli might drive responding more than the underlying affective state would. So we modified a task that had been designed by Keene and colleagues for use with grizzly bears to assess their affect after exposure to enrichment. In their task, the bears learned to make two different responses based on different cues, and one response led to a greater amount of food. So we took this basic idea and we adapted this task also for use for presentation on a touchscreen computer. And we used the same stimulus, a light blue square that was exactly the same with both background cues. However, it varied whether the correct response was to choose the left located square or the square on the right side of the screen. And the cue that signaled which side of the screen was correct to touch was the background color of the monitor. So if the background was white, the correct response was to choose the square on the left. If the background was black, the correct response was to choose the square on the right. Importantly, so that we could assess optimism and pessimism, we also varied the amount of food that was associated with these different responses. So if the background color was white, the correct response was to touch the left square, and the gorillas received 3 pieces of chow. If the background was black, the correct response was to touch the right square, and if they did so, they received 1 piece of chow. So the idea that then, when they've learned this discrimination, they're responding accurately with both background cues, we can then present intermediate gray shades of gray as the background colors of the screen, which now will be ambiguous. They won't know whether the correct response is left or right, but if they're optimistic, they should probably choose the side that signals a greater amount of food. So they should choose left if they're optimistic and right if they're pessimistic. So remember, if they don't make a gamble about what's correct, if they choose the wrong side, they just receive no piece of food. So unfortunately, the gorillas also found this task quite difficult. So if you look at their performance on just the last 100 sessions on the left figure here, you see that Chip basically always chose the left square regardless of the background color, whereas Pende chose, for some reason, the right square regardless of the background color. Congo was a little more variable, but barely above chance, although if you look at the response time data on the right figure on the screen, you can see that Congo responded significantly more quickly on the white background trials, where he would receive the larger amount of food if correct. So that indicates some degree of optimism. So we weren't able to do the testing that we wanted to do because they didn't reach criterion, but I would like to say that we were able to validate this task with a black bear also living at the Detroit Zoo, who learned this task in 9 sessions, just 90 trials, which is amazing performance on a conditional discrimination task. And we were able to give her those test trials under seasonal changes and found that she was the most optimistic when there was a fruiting mulberry bush in her habitat. She really liked those mulberries. So the fact that her choices of the left square, the optimistic response, increased during a period of time when we thought that she would be quite happy, kind of validated our use of the task for us. We've since also used that task with 2 grizzly bears at the Cleveland Zoo, and one of them also was able to learn the task, suggesting that it may be a little more amenable for use for assessing emotional states compared to the ambiguous cue paradigm. But we wanted something that required even less training. So we then turned to a response slowing task that had been developed by Emily Bethell and colleagues and also used by Katie Cronin at the Lincoln Park Zoo. In this task, there really is no training. The individual simply has to touch a gray square appearing in a single location on a computer screen. So 3 different locations a gray square can appear. On the baseline trials, there's nothing in the gray square, they just touch the square. But on test trials, there's either an image of a threatening gorilla or a neutral-looking gorilla inside that square. And the assumption is that under conditions of stress or negative mood state, that responses will be slower. Your cognitive processes are slowed by being anxious or depressed. That's been shown in humans. And so the gorillas should be particularly slow to touch, especially the threatening gorilla image on those threat trials, especially under conditions when they're experiencing stress. So we presented this task during conditions where their environment varied in terms of whether they were given access to their indoor and outdoor habitats or they had access to both. And we thought that they might show the greatest amount of response slowing specifically to the threatening stimulus under conditions where they were in closer proximity and they had less space. But we didn't really see that. What we saw when looking at the individual data is that Chip responded significantly more slowly on baseline trials than to either the threat or the neutral images, which was not what we expected to see. We didn't really see effects in Congo or Pende. And we saw an interaction of conditions where the gorillas were housed the night before and the day before our testing sessions, which occurred in the morning. And we actually saw a slower response when they had access to more space and they could spread out more. But it's possible that they felt they had to be increasingly vigilant because it was harder to know where the other gorillas were in that larger space. We're not really sure. We also wondered if maybe we didn't see strong effects of the threatening stimuli because we presented the same images repeatedly and maybe the gorillas had habituated to those images. So in a second study, we introduced new stimuli, and this time we strictly operationalized threat as a direct gaze from an unknown gorilla versus an averted gaze, which should be less threatening. And now we do see that Chip responds more slowly to threatening stimuli than he does to the baseline or averted gaze stimuli. But we see for Pende, he still responds the most slowly to the baseline stimuli, which maybe he just was more interested in gorilla faces compared to just a gray square. And for Congo, who is the dominant individual, there's not much of an effect, which maybe isn't a surprise because he is dominant and maybe less susceptible to threat. So we followed this study up with yet another study where we actually showed the gorillas images of themselves along with their conspecifics. So they viewed pictures of Congo, Chip, and Pende under the same conditions where their access to indoor and outdoor habitats varied. And this is preliminary, we're still analyzing this data, but we see again, the largest effects in Chip in terms of response time to touching these different stimuli, where Chip actually is the slowest to touch the images of Congo, the dominant individual, but only when the image of Congo was direct, as if Congo was looking directly at him. We don't see this effect under averted gaze, and we don't see any effects for Congo or for Pende. So we do think that examining individuals' responses to dominant threatening versus neutral individuals will be important in other larger gorilla groups. We have also conducted some studies with an emotional Stroop task that others have used as well, or a slightly modified version. And so we continue to explore ways that we can assess emotional well-being. Even though there are clearly some challenges with these tasks, and researchers should be really careful in drawing conclusions when we're inferring underlying emotional states, we do think that these methods borrowed from human cognitive research hold a lot of promise for tapping into their emotional states. And the bottom line is a point that I'd really like to end on, is that it's really important to assess individual differences in this data, these data, because we really do see differential effects of the same environmental manipulations on individuals, and it's important to not assume that the same conditions are beneficial or detrimental across an entire group. So I really appreciate the chance to talk about this work today. I know it was kind of quick, but I'd love to hear from anyone who'd like to hear more about these studies. And of course, I'd like to acknowledge the Detroit Zoo for allowing us to pursue this line of research. We feel incredibly grateful to be able to interact with these amazing animals.